Alright, this is 4.4 notes, additional equations and inequalities. One of the types of equations we see in here is the radical equations, meaning radical meaning a some type of root. Alright, so a cube root, third root, any type of root, or something that involves like x to some type of a fractional exponent. Okay. Now, this is the 5 steps that you saw to do any type of a radical. So you have any type of these type of equations. Now, mainly we're going to do square roots, but I'll go over these with you as we go through a problem, so you can see how it works. So this is a radical equation that we're going to solve, and if you notice, the very first step here says isolate a single radical on one side of the equation. So here's the only radical we have, and we want to isolate it, meaning we don't want this plus 1 over here with it. So I'm going to subtract 1 from both sides to get rid of that 1. And now I've got the radical isolated. So x plus 5, square root of that is equal to x minus 1. Okay. Now, step 2 says to square both sides of the equation. So the reason why we're doing that is because we got this root with an x under it. We want to get rid of that x. We want to get rid of that root so we can have the x out from underneath the root. So we square both sides of the equation. The left side, the square and the root are going to take care of one another, and whatever's underneath the radical just falls out. But the other side, you've got to remember to FOIL this out. Don't just say that's x squared minus 1 squared. You've got to FOIL it. Alright, remember, a square means this thing, whatever is below the square, multiplied by itself. So we FOIL this out, we get x times x is x squared. X times negative 1 is negative 1x, or just negative x. Negative 1 times x is another negative x. And a negative 1 times a negative 1 is a positive 1. Okay, so remember to FOIL it out. And then we got x plus 5 still on the other side. I'm going to combine these two to a minus 2x. And I'm going to leave this x plus 5. Alright, now, I subtract x from both sides, and I subtract 5 from both sides because we've got a quadratic, and we want to solve it by setting everything equal to 0. Alright, remember that's how we solve quadratic equations. So a lot of the times when you do, radical equations, you end up with a quadratic equation because of the fact you have to square both sides. Alright, and now I've got two things two numbers that I need to multiply to negative 4 and add to negative 3. So that's going to be a negative 4 and a plus 1. Okay, so these are my two factored pieces. I set each one to 0. I get the potential solutions that x equals 4, or if I set this one to 0, x equals negative 1. Alright, now, that's step 4. Solve the resulting equation. Okay, we solved it. We got these two possible solutions. Now, what you have to understand is this is no longer a good idea. You've got to check. You have to check your solutions now. So, with a radical equation, you have the possibility of what we call an extraneous solution, meaning something that actually doesn't work, even though it works from the time we square it on, but it doesn't work in the original. So let's check 4. If I plug in 4, I get 4 plus 5 plus 1. Is that equal to the original one? Says x over here, and we're saying x is 4. We're just plugging in this 4 everywhere there's an x in the original. Alright, this is our check. Alright, square root of 4 plus 5 is square root of 9 plus 1. Is that equal to 4? Yes, because the square root of 9 is 3, and 3 plus 1 is equal to 4. Alright, so x equals to 4 is a solution. Alright, now check the other one. I got a negative 1 plus 5. We're taking that square root, adding 1, and then does that equal negative 1? Okay, negative 1 plus 5 is positive 4 plus 1, and as you can tell, this is not going to work. Square root of 4 is 2 plus 1 is 3, and that is not equal to negative 1. Okay, so only one of them worked, the other one did not work, so we throw it away. This is again what we call an extraneous solution. Neous. Okay, it works from the time we squared it on. Like if I plugged it in here, it would work. Alright, negative 1 plus 5 is 4, negative 1 minus 1 is negative 2, negative 1 minus 1 again is negative 2, negative 2 times negative 2, it would be the same thing as the 4 over here. Okay, so it works from the time we square it on, but it doesn't work in the original. So that's what we mean by extraneous. So always check. You've got to remember that that is now a must. Okay, it's not a good idea. Alright, now this one, much more difficult because it's got two radicals. So we can't isolate both of them. We can only isolate one at a time. If I add one over here, now that radical is not isolated. So we can only isolate one radical. Well, notice that's what the first step says. Isolate a single radical. It doesn't say the radical. It says just a radical. So get one of them isolated, and don't worry about the fact that there may be more. So we're going to square both sides from here. It's going to do exactly what we want to on the right, but on the left, again, we're going to have to FOIL because we've got a binomial, even though one of the terms in the binomial is a radical term. But we still have to multiply it by itself. Alright, don't forget that. Don't try to take the easy way out and just square each individual piece, because that's not accurate. That's not correct math. Alright, on the right side again, it's just going to do what we want to. The square and the radical are just going to wipe each other out, and we just get what's underneath the radical. But over here, we're going to have to FOIL this out. So any square root times that same thing is just what's under the radical. So we get the 4x minus 8 to come out. But when we multiply it times this negative 1, we get the negative of the radical, the opposite of the radical. So it's negative square root of 4x minus 8. I'm going to get one more right here, minus the square root of 4x minus 8 again. And then negative times negative is a positive 1. Right, and that all equals 2x minus 5. Alright, these two are going to combine to a negative 2 square root of 4x minus 8, and then this 8 and this 1 are going to combine to a negative 7. So I've got a 4x minus 7 minus 1 square root of 4x minus 8 minus another is minus 2 square roots of 4x minus 8. Alright, equals 2x minus 5. Now notice what this says in our original directions. Square both sides or raise both sides of the power. If a radical remains, repeat steps 1 and 2, meaning now we got to go back and isolate the other radical. So now we're going to isolate this radical by itself by subtracting this 4x adding this 7. Alright, and now all we've got is the negative 2 to deal with. So I got negative 2 square root of 4x minus 8 equals, on this side I've got a negative 2x, and then these two add to a positive 2. Alright, again, I want this radical completely by itself if I can, so I'm going to divide both sides by negative 2. Alright, that's gone. Over here, just notice that if I pull a negative 2 out, alright, it's like dividing each of these terms, so negative 2 divided by negative 2 is just, or negative 2x divided by negative 2 is just x. And then positive 2 divided by negative 2 is minus 1. Okay, so this is the same as this. I'm just pulling out that negative 2 so it'll cancel. Alright, so the only thing I had left on the left side was the square root of 4x minus 8. The only had a thing left on the right side after I did that cancellation was x minus 1. Right? Now, after I've done that, I square both sides again. So I'm going to square the left and square the right. Right? They were equal to begin with. They're going to be equal after we square. Right? Again, the radical and the square cancel with one another. We've got to FOIL this out. So I'm going to write it left to right like this. Alright, holding on to this until we figure out what's on the other side. We get an x squared. Actually, I've already done this one in the last problem. So x squared minus 2x plus 1. Alright, and then finally again I have a quadratic equation. Quadratic because of the square, equation because of the equals. I'm going to combine them together into a single equation and solve. So 0 equals x squared minus 6x plus 9. Alright, this will factor again to x minus 3, x minus 3. So both factors are the same, so we really only need to solve one of them. The only proposed solution is x is equal to 3. It's multiplicity 2, but it's our only solution. So again, we need to go back and check in the original. That's the fifth step. So over here I'm going to do my check. So the square root of the original problem said 4x minus 8 minus 1. Is that equal to this? So 4x we're saying is 3 minus 8 minus 1. Is that equal to the square root of 2? Again, we're saying x is 3 minus 5. Alright, 4 times 3 is 12 minus 8 under the radical minus 1. Is that equal to the square root of 2 times 3 is 6 minus 5 under the radical. 12 minus 8 is 4 minus 1. Is that equal to the square root of 6 minus 5 is 1. Square root of 4 is 2 minus 1 is equal to 1. Okay, so that means this does work, so it is a solution. Alright, but don't forget to check. You've got to check now. Have to check.